IP SLA and enhanced object tracking. Um, what is IP SLA? IP SLA uses active traffic monitoring, the generation of traffic in a continuous, reliable, and predictable manner for measuring network performance. Router generates packets to check service levels. It uses generated traffic to measure network performance between two network devices. Used to measure and verify service levels such as QoS, packet loss, jitter, interpacket delay variance. Uses different types of probes depending on the application being monitored, such as ICMP, TCP, UDP. And it can be tied into object, enhanced object tracking to take actions. So this is actually what we are going to do in this video. Uh, uh, Combine or tie IP SLA into an object, enhanced object tracking. And IP SLAs uses the Cisco RTTMON MIB for interaction between external network management system NMS applications and the IP SLA's operations running on the Cisco devices. So basically you can actually use a NMS application to to get the information that the Cisco devices are reporting, right? And now let's talk about the enhanced object tracking feature. So it provides complete separation between the objects to be tracked and the action to be taken by a client when a tracked object changes. Thus, several clients such as HSRP, VRRP, or GLPB can register their interest with the tracking process. Tracking the same object can each take different action when the object changes. So these are the benefits of tracking. Enhanced object tracking increases the availability and speed of recovery of a network, decreases the number of network outages and their duration, enables client processes such as VRRP and GLPB to track objects individually or as a list of objects. Prior to the introduction of this functionality, the tracking process was embedded with HSRP. So this is an example of tracking the reachability of an IP SLA's IP host. So yeah, an example of this configuration is actually this here. So track and the object number, IP SLA, and the operation number, which is this, and reachability. And of course, you can set the delay up and down. So meaning that, in this case, we're going to use ICMP echo operation. So meaning that, the delay is for the delay of the ICMP operation itself. So yeah, this is the step that we can actually follow. So let me just do this. Step 1, step 2, and step 3. Let me just move it to the right. Yeah, there you go. Okay, and verify. Yeah, that's fine. So this is uh, a procedure that we can follow when we are uh, configuring IP SLA and enhanced object tracking and apply it to a, in this case, we are applying it to default route. So yeah, and this is the references that I have for this video. So I have a topology here. Let me just explain the network or the diagram first. So I have ISP1 and ISP2, and they are connected to the core switch, or yeah, core switch. And core switch has a default route to pointing to 10.0.12.2, and we are just simulating that ISP1 and ISP2 are connected to a router named internet. So let me show you the configurations that I did actually. So let me just go to the core switch. Let me just make the font a little bigger. You know what? That's fine. Yeah, so let me show you the IP SLA here, the IP SLA ICMP echo operations that I have on the core switch. So begin IP SLA. So this is the, yeah, here. So yeah, it's actually very simple. The configuration is very simple. So I am basically pinging this IP here, this, and source IP is my IP address. So 10.0.12.1, and I'm running it forever. So it's actually running. I think I can add every. Oh yeah, you cannot modify it. So I have to remove it first, and then add it again because it's running. And I'm gonna add frequency actually. Frequency is 5 seconds. And then schedule it. So basically run it, run the IP SLA. And let me just verify the configuration. Here. Yeah, so now it has frequency, which is 5 seconds. So it's pinging this IP every 5 seconds. Let me add that here. Okay. Oops, no, not that. Okay, next. Next is actually track the IP SLA reachability. So let me show that to you as well. And I think it's already here. So let me just show you the configuration itself. So configuration is pretty simple actually. So track object, so 100 in this case, and then I'm tracking IP SLA, yes, and then the number is 100, and I'm tracking its reachability. Okay, and then the delay is basically, you know what, let me do it again. Yeah, delay is down is 10 seconds. Yeah, 10 seconds in this case, and up is 10 seconds as well. Yeah, And then I have, like I said earlier, I have a default route pointing to this here, to ISP1. So I actually have a tracking object applied to that route, to that default route, which is this. So let me show that to you. Okay, here. So yeah, so it's basically saying that when this tracking here goes down, this IP route or default route will not be in the routing table anymore, and this route here will be installed on the routing table instead. So, or default route I should say. And this is how you verify it. So show track. So reachability, sorry, track is 100, IP SLA 100, reachability is up, delay up 10 seconds, down 10 seconds, latest operation return code, okay. Yeah, latest RTT milliseconds 1, tracked by static IP routing. So uh, in other words, it is applied to the static routing that not so really sure about this, but in our case, um, it is applied to the default route that here, right? Where is that again? Here. So it is applied to the default route that on this device. So let me just do some verification here. So let me ping. I actually have another IP here. That is that /32. Let me ping that IP address. Yeah, I can ping it. And let me trace route to it. I think it's gonna take a few seconds because I think my laptop is actually, I think it has to do with the memory of my laptop, but it should trace route to it. So next step is ISP1 because our default route is pointing to that IP address, and then to the internet router here, and then that's the last hop, and I mean we get to that destination. So let us actually try to um, shut down ISP1 gig 0/1. I mean gig 0/0, so that that tracking or that IP SLA and tracking will both go down actually. Yeah, I think they will both go down, but like we can verify that. And actually before I shut down interface, I'm gonna show you this command, the output of this command. So type is ICMP echo, so meaning that we are pinging this IP basically, and there's another there. So we are pinging this IP and uh, from source address, which is this here. Okay, so yeah, IP SLA is looking good. Yes. Yeah. And let me show that here. Oh, IP SLA statistics. This is another command that we can use. So number of successes, 61, and number of failures is 0. So it is running fine. So let me go to ISP1 and let me just make the font a little bigger. So I'm going to shut down 0/0 here. Shut it down. And I'm going back to the core switch and see if I can still ping it. Yeah, should not be able to ping it. And we are going to check or verify the tracking trace route. I'm going to add that command. Ping as well. Okay, so show track. Let's try show track. Yeah, it says down, and we have a log here that says track 68 IP SLA 100 reachability up to down. So it went down, and then we can do this. Yeah, so it went down as well. So we see that both IP SLA and tracking are down. So let's check the routing table now. Yeah, we need to add that command as well. Let's say verification command. So now if I do show IP route or check the routing table of the core switch, the default route is now pointing to ISP2. And let me trace route or ping. Yeah, it works. I think it will take a few seconds. While that's running, let me just check here. Yeah, looking good. I'm going to add this to the description of this video so you can check this yourself as well. Okay. Wow. I'm not sure actually if core would be able to trace route to that IP address. Let's see. So while that's running, so you see that this is just the log of the port that went down. Yeah, so we are able to trace route to that IP address, and the next hop is ISP2, and it gets to the internet router here, this IP address here. So yeah, it's working as expected. Let me just no shut this interface again. Save. And we expect that show IP SLA summary will actually come up, or actually I can just check the tracking because it is already tracking the IP SLA itself. And that is in this, that would be our step number 2 here. Still down. So we said here that I think it's gonna wait for up to 10 seconds because of the delay that we set up. 10 seconds here. And of course it could have to do with my computer itself being, yeah, okay, now we see 9 seconds remaining. 8 seconds remaining. 4 seconds remaining. 1 second remaining. Yep, so we see a log that says reachability down to up. So now we expect that our default route is now pointing to ISP1, which is the case here. Yeah. And let's see if we can ping to that IP address again. Okay. And trace route again to that. Which is going to take a few seconds. This is actually a good step or procedure. Let me say procedure. Is that same? Yeah. Let me just, there you go. Okay. Yeah, now we can trace route to it. Let me do show IP route again. Yeah, it is pointing to, default route is pointing to ISP1. Okay, yeah, that's it in this video. If you like this video, please don't forget to like the video and subscribe to this channel. Thanks for watching.